Hello, am I audible?
Yes, sir.
Okay. Okay. See, good afternoon to one and all. In the previous practical, we have just familiarized regarding electrical machine 1 laboratory. So I have given introduction related to machine 1 laboratory, that is electrical machine 1, which equipments, how the ratings of the current rating or maybe voltage rating of the meters are selected, which are the panels in that electrical machine 1 laboratory. So we have totally familiarized, or for introduction I have already given regarding electrical machine lab in the previous practical. Okay, so in the previously we have also seen some of the equipment or some of the setup to conduct. Here we want to conduct the practical. So I have tell that there are different types of practical, like speed control technique, like finding the magnetization characteristics, also finding the efficiency of the DC shunt motor, finding the efficiency of the DC shunt DC series motor. Also we want to find out the efficiency by conducting test on the transformer. Again we want to find out the efficiency by using the Hopkinson test, or it may be Swinburne test. So these all types of introduction and the familiarization of the electrical machine 1 laboratory we have already discussed in the previous one practical. Okay, that means introduction of electrical machine 1 laboratory we have already discussed. Now today we will discuss about our first one practical, and we will perform this practical physically. First of all, we will do the discussion. What is that practical aim, title, which apparatus it can be required, then what is the procedure, what is the circuit diagram. So we will discuss primary first. After that we will do the actual connection, run the machine and take the reading. Okay, see, today we will discuss about the first one practical, that is experiment number 1, determination of magnetization, then external and internal characteristics of DC generator. Okay, so in the theory we have discussed the determination of magnetization characteristics, that is magnetization characteristics, or it is called as OCC curve, open circuit curve, or it is called as no load curve. We have already drawn and discussed in while discussing regarding theory. Also we have drawn some of the external characteristics and the internal characteristics of DC generator. DC generator चे आपण characteristics we have already discussed, no? बघितलेत ना characteristics, OCC characteristics, external and internal characteristics. बघितलेत ना? Give me reply. Hello. Yes, give me reply. All of you present, no?
Yes, sir.
Okay, just give me reply. So we have already discussed the magnetization characteristics, external and internal characteristics of DC generator. So today we will find out the characteristics, that is magnetization characteristics or the open circuit characteristics, or it is called as no load characteristics of DC generator. So this is the title of today's experiment, that is experiment number 1. Now the aim of this experiment is that to obtain the OCC characteristics, that is to obtain the open circuit characteristics, it is called as a magnetization characteristics of the given DC shunt generator, and hence to determine the critical field resistance. आपल्याला critical field resistance काय करायचं, determine करायचं. So while conducting this test, what is apparatus it can be required? So apparatus required for the conduction of this test is that the voltmeter having a range 0 to 300, the quantity it becomes 2 quantity. So for measurement of supply voltage and for measurement of induced EMF. So this 2 voltmeter we required. After that we required 2 ammeter. So 2 ammeter, sorry, 1 ammeter for measurement of field current. For IF measurement we required a 2 ammeter. So see, we are selecting here range 0 to 2. Actually we are selecting either it may be 0 to 5 ampere range or it may be 0 to 10 ampere range, but the accuracy of that meter, when we select the accurate rating meter, ज्यावेळेस आपण accurate rating चा meter जर select केला, then we will get the more accurate reading. Okay, so rheostat, we required 2 rheostat. One is series with that of field of the motor, another one is the series in with that of generator field. Okay, then we required 2 rheostat having an 200 ohm and 1 ampere of the current. So it required a 2 quantity. Then tachometer, for measurement of speed we required 1 tachometer. For speed measurement we required a tachometer. So these are the apparatus required for performing this test, that is to obtain the OCC characteristics or open circuit characteristics. It is called as magnetization curve or the magnetization characteristics of DC shunt generator, and hence to determine the critical field resistance. Okay, see, we will discuss regarding theory related to that. So we have already discussed in the theory, but also before discussing regarding practical, we will discuss the theory. See, do you know that the open circuit characteristics, that is magnetization characteristics, it gives an relation between the no load induced EMF in the armature, that is E0, versus field current IF. आपण characteristics बघितलेली होती बघा while studying the theory. Just these characteristics, it will be like this. The no load induced EMF is plotted on y-axis. Then field current it can be plotted on x-axis. X-axis la field current plot केला होता. Now this curve it will be obtained like this. So before exciting the field winding excite होण्याच्या अगोदर, that means at a 0 value of field current, it will show some of the induced EMF. Why it will show some of the induced EMF? What is the reason behind it? We have already tell, but can anyone tell me? See, this curve it will be like this. It will start from here. It will after that it will be straight line. After that it will be some that means it will be straight line position. It can be changes. After that it will be a constant value. Can anyone tell me why this induced EMF at 0 value of field current it will be present? What is the reason behind it? काय reason आहे? 0 value of field current, त्याच्यामध्ये काहीतरी induced EMF present असतो. So curve it will be start from some of the induced EMF. What is the reason behind it? OCC curve, magnetization characteristics किंवा open circuit characteristics. We have wasted 1 hour lecture for that only one curve, that is OCC curve. Can anyone tell me? Suppose I will give the name. Suppose here it is O, up to that O to A, then after that A to B position is there, and again here C position is there. So this curve it can be divided into 4 parts. What is this first part? 0 to A, O to A.
Saturation.
O2A, it is the whether it is saturation. मी सांगितलं होतं in Marathi also, at a zero value of field current, ज्यावेळेस field current 0 आहे, at that situation there are also some of the induced EMF is present. field current 0 असताना काहीतरी induced EMF present आहे, so this induced EMF is shown by O2A. So why this induced EMF is present? What is the reason behind it? कशामुळे तो induced EMF present असतो? I think this point we have already discussed in the last 2 or 3 lectures. पाठीमागच्या 2 ते 3 लेक्चर मध्ये आपला हा पॉइंट झालेला आहे, that is magnetization characteristics. I have already explained in the theory, but also I am explaining here also because we want to perform the practical. What is 0 to A? हा कर्व 4 पार्ट मध्ये डिवाइड आहे बघा. 0 to A to B, B to C and after C. Can anyone able to tell? Give me reply. Can anyone able to tell? If anyone are able to tell, then tell. Otherwise just say no. माहिती आहे कोणाला? Just give me reply immediately. Don't waste the time.
No, sir.
Okay. See, I have already tell at a zero value of field current. That means there is a no field current. So if there is a no field current, there are some of the induced EMF is present due to the residual magnetism. I have tell no. सांगितलं होतं का मी? सांगितलं होतं. Due to the residual magnetism, there is some of the induced EMF. It will be present before exciting of the field winding. बिफोर एक्साइटिंग म्हणजे फील्ड वाइंडिंग एक्साइट करण्याच्या अगोदर, म्हणजेच आर्मेचर करंट फील्ड करंट हा 0 आहे. At that condition, there is some of the induced EMF. It will be present. It is due to the residual magnetism. Whether I have tell or not, सांगितलं होतं का नव्हतं? Give me reply immediately whether I have tell.
Yes, sir.
Okay, I have already tell no. See, before exciting of the field current, that means when the field current it will be 0. Field current it will be 0. At that situation, there is some of the induced EMF. It will be present. This induced EMF it can be shown by O2A. ज्यावेळेस फील्ड करंट 0 आहे, म्हणजे फील्ड वाइंडिंग एक्साइट केलेली नाहीये, त्या कंडिशनला जनरेटर मध्ये सम ऑफ द इंड्यूस्ड EMF असतो. सो दिस इंड्यूस्ड EMF it will be shown by O2A, and this induced EMF it is due to the residual magnetism. It will be present in the pole before exciting of the generator. After that, see, after that, if the field current it will be increases, if the field current it will be increases, the induced EMF it will be increases, and it gives an linear relationship. So this curve shown by A to B. A to B ने जो दाखवलेला कर्व आहे, so this line it will be shows that the linear relation between the field current and induced EMF. Induced EMF आणि field current ची linear relationship. Okay, so at that situation, there is a reluctance of the iron core. It should not taken into account, and the flux distortion or it may be leakage flux, it should not be taken into account. त्यावेळेस आपण लिकेज रिॲक्टन्स आणि जे काही फ्लक्स आहेत, So this flux distribution, it will not taken into account air gap flux, and the reluctance of that of iron path, it should not be taken into account. So the curve shows that the linear relationship. What is linear relationship? Linear relationship, meaning of linear relationship. लिनियर म्हणजे जेवढा करंट इन्क्रीज होईल तेवढाच इंड्यूस्ड ईएमएफ इन्क्रीज होतो. दॅट मीन्स current increases by some value, then induced EMF, it will be also increases in that proportion. That means E0 is directly proportional to IF. E0 आणि IF चं काय आहे? Direct proportion. After that, that means after point B, the curve it will be deviates from its linear relationship. कर्व जो आहे तो त्याच्या लिनियर रिलेशनशिप पासून काय होतो? डेव्हिएट्स होतो. सो द कर्व it will be deviates from linear relationship. Why? Because the reluctance of the iron core, it should be taken into account. Reluctance of the iron core, it should be taken into account. Also the air gap flux, it should be taken into account. Air gap चे जे काही फ्लक्स असतील, this is also taken into account. त्यावेळेस reluctance and air gap flux, it will be taken into account. That is leakage reactance, it will be taken into account. And the curve, it will be deviates from its linear relationship. That means if the field current increases, the induced EMF, it will be increases and it will changes its relationship, that is linear relationship. तो linear relationship पासून काय होतो? डेव्हिएट होतो, म्हणजे तो linear relationship शो करत नाही. Okay, now after point C, if we again increases the field current, परत जर आपण field current increase केला, then the induced EMF of the machine or the generator, it remains constant. Why? Because it is constant. का बरं तो constant राहील? परत मी field current increase केला तर if we again increase the field current after point C, the induced EMF is constant. What is the reason behind it? Why it is constant? I think you are not doing the study. No one is seen YouTube lecture of any subject. कुणी YouTubeचं lecture बघितलेलं नाही. I have already sent the teaching diary. In that all subject YouTube lecture are uploaded. Okay, so link of that lecture is there. If you have not understand the concept at the time of lecture, just see the YouTube lecture or video. So according to this, you will better understand. But you are not doing study like that. I have already tell, but also you are not able to say something. That means there is a lack of understanding. Okay, see, after point C, that means if again field current, it will be increases. परत जर field current increase केला, then the induced EMF, it will be constant. That means there is a saturation of magnetic flux, it will be happen. Magnetic flux काय होतं? Saturation होतं. So after saturation, I have already tell the saturation concept also. So after saturation, if again increases the field current, then the induced EMF of the generator remains constant. Okay, so this is the magnetization characteristics or the open circuit characteristics. This magnetization characteristics, it is same for all types of generator. All types of generator साठी same असेल, whether it is separately excited generator, whether it is self excited generator, or it may be DC shunt, DC series generator, or it may be compound generator. So these characteristics, it is same for all types of generator. So we want to derive or we want to determine these characteristics by performing the practical. By performing the practical, we want to determine these characteristics. ही characteristics आपल्याला काय करायचे? Determine करायचे. See, the magnetization characteristics, it is nothing but it is the relation between no load generated EMF in the armature E0 and the field or exciting current IF versus E0 आहे. The speed of the generator remains constant. We are maintaining the speed of the generator remains constant. So for making the speed constant, we are using the speed governance system. Speed governor आपण use करतोय for maintaining the speed constant. These characteristics are known as the no load characteristics or the open circuit characteristics. याला open circuit characteristics, or we can call it as a no load characteristics. The shape of these characteristics is practically same for all generator, whether it is separately excited generator or it is self excited generator. Separately excited generator असेल किंवा self excited generator असेल, याचा जो काय shape असेल, it is same. That means curve, it will be divided into 4 part: O to A to B, B to C, and after C. Okay. Due to the residual magnetism in the pole, some EMF is generated even whether IF is 0. See here, explanation is given. ज्यावेळेस IF 0 असेल, some of the induced EMF it will be present, or EMF it will be generated. So this is due to the residual magnetism. It will be represented by curve OD. So this curve it will be shown in this model graph. We have already taken the model graph here. याच्यामध्ये model graph घेतलेला आहे. So see, OD is nothing but some of the induced EMF. It will be present at zero value of field current. Field current च्या zero value ला induced EMF काय आहे? Present आहे. Okay. Now the curve start at a little way of the straight curvature DE at the lower end is due to the magnetic inertia, and it is seen that the first part of the curve EC is practically straight. हा याच कर्वचा जो काही नंतरचा पार्ट असेल, that means part AB, it will be linear or it may be a straight curve. If field current increases, the induced EMF it will be also increases. Now this is why it is linear. This is due to the fact that at low flux density, reluctance of the iron path being negligible. Reluctance of the iron path it becomes negligible due to high permeability, and the total reluctance is given by the air gap reluctance, which is constant. So reluctance जो आहे तो negligible असेल. So reluctance in the iron core or the reluctance in the iron path it is negligible. So the induced EMF and the field current it will gives a linear relationship. त्याच्यामुळे ते काय करते? Linear relationship show करते. Now after that, hence the flux are consequently generated EMF are directly proportional. Flux आणि generated EMF काय राहील? Direct proportion राहील. So it will give the linear relationship. However, at the high flux density, ज्यावेळेस flux density increase will, that means however the flux density it will be increases, and high flux density will be there. The permeability of that material, it is mu, it can be small, and iron path becomes appreciable and the straight line. So CF between E0 and IF no longer hold good, that is saturation of pole start. Okay, so after that it will be deviates from its linear relationship. So त्याच्या linear relationship ला deviates करेल. Okay, once the linear relationship it can be deviates, then after point C, if we again increases the field current, so the induced EMF becomes constant. Induced EMF काय असेल? Constant असेल. Okay. Now getting all of you OCC curve. OCC curve लक्षात आला का? Okay. See, after that we are able to find out the critical resistance. Critical resistance पण आपण find out करू शकतो. Critical resistance is nothing but at what resistance the induced EMF at constant value. So this is the critical resistance. It is that maximum value of field resistance above which the machine fails to excite. Okay. So हा जो काही critical resistance असेल, it is the maximum value of field resistance. Fieldचा maximum resistance, above that resistance the machine fails to excite, म्हणजे मशीनला एक्साइटेशन प्रोव्हाइड होत नाहीये. That means zero current it will be provided. There will be no build up of voltage. Voltage build up होणार नाहीये. This resistance it will be corresponds. This resistance corresponds to the straight line position of the magnetization characteristics, because the magnetic circuit does not offer any appreciable reluctance to the magnetic flux. Okay, so this one is the critical resistance, and the critical speed is that it is the speed for which the given shunt field resistance will represent the critical field resistance. म्हणजे जे ज्या स्पीडला given shunt resistance जो आहे, it will show that the critical field resistance. Okay, critical field resistance. So this speed is nothing but critical speed, or it is that minimum value of the speed of the machine below which the machine fails to excite. त्या स्पीडच्या बिलो स्पीडला मशीन एक्साइटेशन काय करेल, फेल करेल. So this is the critical speed. Okay, now we will discuss regarding the diagram, that is connection diagram. See, circuit diagram or the schematic diagram for this performance of this test. ही टेस्ट परफॉर्म करण्यासाठीची सर्किट डायग्राम. See here, there are motor generator set, it can be used. So the motor and generator, in between that there is a direct coupling. या दोन्हीच्या मध्ये बघा डायरेक्ट कपलिंग यूज केलेलं आहे. So these are direct coupled to each other. This one is the motor, DC motor. This one is the generator. We are direct coupling between that motor and generator. See, for limiting the starting resistance of the motor, that means to start the motor, we required one of the starter, that is 3-point starter. एक 3-point starter पाहिजे आपल्याला. Okay, we required a 3-point starter. Now with the help of 3-point starter, so with the help of 3-point starter चा यूज करून आपण काय करतोय, मोटर सेफली स्टार्ट करणार. and one of the rheostat, it can be connected in series with that of field winding of the motor. मोटरच्या field winding च्या series मध्ये एक rheostat कनेक्ट केलेला आहे. by varying this value of resistance, याची व्हॅल्यू व्हॅरी करून आपण काय करणार, मोटर it will be runs at a maximum speed or the rated speed. मोटरचं जेवढं रेटेड स्पीड आहे त्या स्पीडला अगोदर मोटर काय करणार, रन करणार. once the motor it can be started or motor it can be running on rated speed, so there is a direct coupling between motor and generator. Okay, whether the generator is running on same speed as that of motor, generator मोटरच्या सेम स्पीड न रन होईल का डिफरंट स्पीड न रन होईल?
सेम स्पीड
because there is a direct coupling. जर मोटर 1500 rpm ला रन होत असेल, 1500 रिव्होल्यूशन पर मिनिट, 1500 रिव्होल्यूशन पर मिनिट ला जर मोटर रन होत असेल, because there is a direct coupling between these two shaft, the generator it will be also running on 1500 revolution per minute. म्हणजे सेम स्पीड ला रन होईल. रेटेड स्पीड ला आपण मोटर पहिल्यांदा रन करणार by varying this rheostat. once the motor it can be running on the rated speed, the generator it should be also running in rated speed, and we will make this speed as a constant. ते स्पीड आपण constant maintain करणार. Okay, now after varying the resistance or the rheostat which is connected in series with that of field winding, field winding च्या series मध्ये कनेक्ट केला जो काही रेजिस्टन्स आहे, so by varying this value of resistance, हा रेजिस्टन्स व्हॅरी करून आपण व्होल्टेज चेक करणार. Okay, we are checking the voltage, by varying the resistance, which are connected in series with that of field winding of the generator. जनरेटरच्या फील्ड वाइंडिंग मध्ये कनेक्ट केलेला जो काही रेजिस्टन्स असे आहे, दॅट इज रिओस्टॅट. तो रिओस्टॅट व्हॅरी करून आपण करंट व्हॅरी करणार. once the current it can be changed, that means we are increasing the current flowing from that. याच्यामधून फ्लो होणारा करंट काय करतोय, इनक्रीज करतोय. so once the current it can be increases, we are observing the induced EMF by using this voltmeter. या व्होल्टमीटरचा यूज करून induced EMF काय करणार आपण, ऑब्झर्व करणार. ओके, when the current increases, whether induced EMF is increases or decreases, and after that we are able to plot a graph. त्याच्यावरून आपण त्याचा ग्राफ प्लॉट करणार. so this graph obtained is nothing but OCC characteristics. तो जो काय येणारा ग्राफ असेल So this graph is nothing but open circuit characteristics. Okay, see the procedure for that. The circuit connection are made as per the circuit diagram. जशी सर्किट डायग्राम आहे त्याच्यानुसार सर्किट डायग्रामचं कनेक्शन करून घ्यायचं. कीपिंग द मोटर फील्ड रिओस्टॅट इन इट्स मिनिमम पोझिशन. मोटरचा फील्ड रिओस्टॅट जो आहे इट विल बी कीपिंग इट्स मिनिमम पोझिशन अँड जनरेटर फील्ड रिओस्टॅट इट इज मॅक्झिमम पोझिशन. जनरेटरचा फील्ड रिओस्टॅट जो आहे दॅट मीन्स फील्ड रेजिस्टन्स जो आहे तो मॅक्झिमम पोझिशनला काय करणार आपण केप्ट करणार. And by using a starter, initially the starter is in at off position. The main supply is switched on. Main supply is switched on. By varying the starter, that is 3-point starter, by varying the arm slowly, we are starting the motor from no load to full load. That means we are starting the motor from its zero value of current to the rated current. The motor, it can be started using the 3-point starter by slowly and carefully moving the starter handle from off to on position. The motor to brought to its rated speed. Javades motor it will brought its rated speed by adjusting its rheostat, and checked with the help of tachometer. Tachometer चा यूज करून आपण काय करणार स्पीड चेक करणार. ओके, वी आर चेकिंग द स्पीड with the help of tachometer. With the switch open, the residual voltage is noted. So we are not using here switch, so we are directly taking the reading of field current. After that, now switch is closed and the generator field rheostat is varied in step, and at each step the field current IF and the corresponding induced EMF E0 are recorded in the tabular column. After that, we are recording the induced EMF and we are recording the field current. This procedure is continued until generator voltage reaches 120% of its rated value. ही procedure आपण repeat करणार up to what the generator it will reaches its 120% of rated value of the machine. While speed it can be maintained constant. And after the experiment is completed, the various rheostat are brought back to the original position. परत connection remove करायचं. Before removing the connection, जी procedure perform करताना केली होती त्याच्या reverse procedure करायची. First of all, we are varying the rheostat, and one rheostat it can be keeping at a minimum position. One rheostat it can be keep at a maximum position. After that, we will switch off the supply and then we will remove the connection. Okay. So these are the procedure. This one is the procedure for conducting this test. Test conduct करण्याची procedure. Now this is the observation table. So for observation table, first of all write the speed of the generator. All of you take screenshot of this observation table. Observation table चा screenshot घ्या because we want to write the reading. All of you take screenshots. First of all write the speed of the generator. It is in RPM and this is the constant speed. जे आपण maintain करतोय ते speed लिहायचं. That is constant speed. After that, take the reading of field current and the generator voltage. First one reading. By varying the rheostat, take the second reading of field current and the generated voltage. Third one reading of field current and generated voltage by similarly varying the resistance. Resistance vary करून आपण त्याचं reading घेणार. Okay. So this is the observation table. And this one is the model graph. So in case of this model graph, O to D, there are some of the induced EMF it will be present due to the residual magnetism. This curve it will be start from this position. After that it will show some of the linear relationship. हे linear relationship दाखवेल. After that it will be deviates from its position. C to F पासून ते position काय करेल deviates करेल. Okay, it will be deviates from its position, and after that point it will be the constant when we increase the field current. Again increasing field current, the value of it becomes constant. त्याची value काय असेल constant असेल. And this is the field current at this maximum field current. ह्या maximum field current ला त्याची value काय राहील परत constant राहील. So this is the model graph related to that of magnetization curve, or it may be OCC curve. OCC curve चा model graph. Then the result and conclusion, that is result. the magnetization curve, that is magnetization characteristic curve, it can be drawn, and the value of build-up voltage is obtained from the graph. Graph वरून value of build-up voltage it can be obtained. Okay, so and the critical resistance it can be determined from the graph. So this is the result, and you will tell the conclusion. After that you will tell the conclusion once we have performed the practical. Let us practical perform karu. After that all of you tell the conclusion to me. Okay, can we perform? We will do the connection, that is we will do the connection and we will perform. All of you understand this theory? या practical ची theory लक्षात आली का तुमच्या?
Yes, sir.
Okay.
Yes, sir.
All of you visible the screen? Hello.
Yes, sir.
Another one, I have started the camera. त्याला पिन करून ठेवा तुम्ही. Just pin to that number, so it is visible to all. All of you visible, no?
Yes, sir.
हा स्क्रीन दिसती नाही सगळ्यांना?
Yes, sir.
Okay.
Yes, sir.
Okay, see, just okay, see, I have explained the connection diagram already. I have already explained the connection diagram. We will do connection first. याच्यावरून आपण connection करूया. After that, we will run the machine. See, here it is positive and negative supply. That is positive and negative DC supply. So this terminal, that is one positive terminal of the supply, it can be connected to one line terminal of the 3-point starter. 3-point starter च्या line terminal ला connect केली. After that, the field terminal of the 3-point starter, 3-point starter चे जे काही field terminal आहे, so this terminal it can be connected to one terminal of the rheostat. It is connected to one terminal of the rheostat. Rheostat चे एका terminal ला connect केलं. Next terminal of the rheostat, it can be connected to the F1 terminal of the field winding. Motor ची जी काही field winding होती, so see here, the motor is there. इथं motor आहे, त्याच्या field winding च्या F1 terminal ला connect केलं. Now F1, F2 and A2 it gets short circuited. F1 A2 short circuit केले, and the next one connection is that armature terminal of the 3-point starter. 3-point starter चा armature terminal, that is A terminal. A terminal of the 3-point starter, it can be connected to that of A1 terminal of the DC motor. Okay, motor आणि generator set आहे, coupling आहे, DC motor च्या A1 terminal ला connect केलं. Okay, now the negative terminal, that is A2 F2 get short circuited, A2 and F2 short circuit केले, and one terminal is taken and it is connected to negative terminal, supply च्या negative terminal. So this is the first one, motor connection. हे motor connection आहे. Now we will do the generator connection.
सी मोटरचं कनेक्शन आपण कंप्लीट केलंय बघा. पॉझिटिव्ह टर्मिनल ऑफ द सप्लाय इट कॅन बी कनेक्टेड टू लाईन टर्मिनल ऑफ द 3 पॉइंट स्टार्टर. Field terminal of the 3-point starter, 3-point starter is a field terminal. It can be connected to one terminal of the rheostat. Next terminal of the rheostat, that is variable terminal of the rheostat, it can be connected to F1. Then F2, A2 gets short circuited and it is connected to negative supply. Armature terminal of the 3-point starter, it is connected to the A1 terminal of the motor. So this one connection we have completed. After that, see, the generator armature terminal and the field terminal of the, see, we will connect A1 terminal, that is here, this one is the armature A1 terminal of the generator. Generator चे terminal आहे ते आपण rheostat च्या एका terminal ला connect करतो. So we are not using switch here. So we are just connecting it to the one terminal of the rheostat. Rheostat चे एका terminal ला मी connect करतोय. Now, next terminal of the rheostat. Next terminal of the rheostat. That is variable terminal of the rheostat. It can be connected to the ammeter terminal. एक ammeter terminal ला connect करायचे. So I am just connecting this. That is next terminal of the rheostat. जे काय rheostat चं next terminal आहे. I will connect this terminal to the ammeter one terminal. Ammeter च्या positive ला connect करतो मी. So positive terminal of the ammeter. After that, the next one terminal of the ammeter, ammeter चे काय next terminal आहे, it can be connected to the field F1 of the generator. Generator चा F1, that is F1 terminal of the field winding of the generator. Generator चा F1 ला. Now F2, A2 get short circuited. याचा जो काय F2 आणि A2 आहे, so that is A2 and F2. Armature A2 terminal, field से F2 terminal, it becomes short circuit. It becomes short circuit. Now, for measurement of voltage, that is induced EMF measurement साठी we required one of the voltmeter to measure the voltage. Voltage measurement साठी एक voltmeter पाहिजे. So this voltmeter, it can be connected across armature terminal A1 आणि next one terminal, that is A2. Armature च्या A1 A2 terminal ला मी एक voltmeter connect करतोय. So I am connecting here voltmeter 1. Okay, one of the voltmeter, it can be connected to measure the armature voltage. To measure the supply voltage, एक voltmeter पाहिजे आपल्याला measurement. For measurement of supply voltage, we are using here multimeter. Just I am using here multimeter. So just I will connect here multimeter. Okay. See, simple connection is that. It's a connection simple आहे. बघा काय केलं. Positive terminal of the supply, then negative terminal of the supply. Positive, negative आहे. Positive terminal of the supply, it can be connected to the line terminal of the starter. Positive terminal of the supply, it can be connected to the line terminal of the 3-point starter. After that, the field terminal of the 3-point starter, it is connected to one rheostat terminal. Rheostat से एका terminal ला connect केले. Next terminal of the rheostat, it can be connected to the field winding F1 terminal. हे मोटरचं connection आहे, मोटरची field winding F1. See, armature terminal of the starter, it can be connected to A1 terminal. A2 F2 gets short circuited and it is connected to the negative supply. A part complete झाला. Next one part is that generator A1 terminal, it can be connected to the rheostat 1 terminal. Rheostat चे एका terminal ला connect केले. Next terminal of the rheostat, it can be connected to one of the ammeter to measure the field current IF. Next terminal of the ammeter, it is connected to F1 terminal. F2, A2 get short circuited. दोन्ही काय केले? Short circuit केले. And to measure the voltage, induced EMF voltage, so we required one of the voltmeter and we are connecting these across A1 and A2. A1 and A2 च्या parallel मध्ये आपण काय केले? एक voltmeter connect केले, having a range 0 to 300. Okay. All of you understand the connection?
Yes, sir.
Sir.
Yes. Hello.
Yes, sir.
Understand no? Connection?
Yes, sir. Yes,
sir.
sir.
Can we perform the practical?
Yes, sir.
Okay. See. Okay. In the introduction, I have already told that the supply is given to the top machine because it is DC machine. Supply requirement is DC. So here it is one of the rectifier end is there. I have already shown the rectifier end. First of all, I will start that rectifier unit. If I am the rectifier unit start करतो, so that we will get the DC supply. Okay. So I will start the rectifier. Here it is DC on. I want near about 200 to 220 volt voltage. So by wiring this port, I am setting one of the voltage, that is DC voltage, up to 200 or 220 volt. Okay. Okay. See, I have set this value of voltage. It is near about 220. Okay. Or 200. After that, switch on this MCB. It will show some of the voltage. Here the supply voltage, it is near about 200 or 220 volt. Connection. What is the voltage? DC voltage? किती आहे reading? Tell me the value of voltage. Voltage ची value सांगा. Analog meter connect केले मी. Read the value of voltage.
110.
110. See the connection where it is connected. Connection कितीला आहे?
300.
150 and 300 दोन स्केल आहेत. मी 300 ला कनेक्ट केलंय. व्हॉट इज द व्हॅल्यू ऑफ व्होल्टेज नाउ?
दिसत नाही.
दिसते का नाही?
Yes sir.
हा विजिबल.
Yes sir.
हा सी रीड द व्हॅल्यू. किती आहे व्होल्टेज?
115.
100, 120, 140 and 150. This is the scale for when it is connected to 150. Now it is connected to 300. What is the reading?
115.
Again 150, 115. अरे 150 ला जर कनेक्ट केला असेल तर ही दाखवलेली स्केल तुम्ही घेणार. मी कनेक्ट केलं 300 ला. किती येईल रीडिंग? 110 आहे. 110 ला
Sir,
मल्टिप्लाय
220.
करावं लागेल ना.
220.
हा जस्ट that I am asking. You are telling directly I am connected it to 300 volt. You are seeing the result of 150 volt. मी 300 ला कनेक्ट केले, तुम्ही 150 चं मला व्हॅल्यू सांगताय. सो इट इज 110. 300 ची स्केल म्हटल्यानंतर हे डबल घ्यायला पाहिजे ना. 110 into
Yes.
2 is nothing but 220, right? So supply it can become by using a 3-point starter. By using a 3-point starter. By using a 3-point starter, by slowly varying the 3-point starter, I am starting the DC machine. Okay. By varying the 3-point starter, हा जो काही 3-point starter आहे तो vary करून मी machine safely start केली. Now we will measure the voltage and the speed. Now we will check the speed of the motor. Motor की speed check करूया आपण by using a tachometer. All of you write the reading. The speed of the DC motor, which is coupled to that of generator, is that 1749. Okay, so we are maintaining some constant speed. We are already reached the maximum value because the rated speed of the machine it is 1500. Okay, 1500 RPM आहे rated speed, but we are reaching the maximum value. So we are not varying this rheostat to increase the speed. Now, by changing the value of rheostat, which is connected in series with that of generator. See, generator च्या series मध्ये connect केला resistance जो आहे तो व्हॅरी करून आपण करंट चेक करणार. So while checking the current, we will show the reading of induced EMF. Okay. See, I am wearing this rheostat. Zero to 2 ampere का हा आहे का हा मीटर हे reading. 0 to 2 ampere.
सर आवाज येत नाही.
येते का? 0 to 2 ampere चा आहे. स्क्रीन दाखवली पण मॅक्झिमम मला. घेऊन येतो मीटर पलीकडे. We will connect.
औषध चालू आहे का? रेटिंग चालू आहे का? बघ की येतंय.
चालू आहे का नाही? चालू आहे हो. कॅमेरा केलं काय? मीटर कनेक्ट करू. ओमन milliampere. दोन एम्पियरचा मीटर तुम्ही जोडल्या मिलियम्पियर असेल करा की प्रोसेस मायक्रो एम्पियर ठीक आहे मिली एम्पियर See speed. We will check the speed. Right. See, check the speed. 1800. Very good. 1807. Okay. Speed of the DC shunt motor, it is equals to 1807. All of you take this reading. So we are maintaining the speed of the machine constant, and after by varying the field resistance, जनरेटरच्या फील्ड मध्ये कनेक्ट केलेला जो काय रेजिस्टन्स आहे तो रेजिस्टन्स व्हॅरी करून आपण इंड्यूस्ड ईएमएफ चेक करणार. सी द इनिशियल व्हॅल्यू ऑफ करंट. किती आहे करंटची व्हॅल्यू? हॅलो 0.77 milliampere. So we are connected it to milliampere. See here it is shown that is milliampere, 0.77 milliampere. Okay, at that situation check the induced EMF. Is the induced EMF? Hello, induced EMF. It is near about in between 0 to 40. That means it is near about equal to 20. We are varying the resistance which are connected in series with that of field winding of the generator. Generator field winding च्या series मध्ये जो कनेक्ट केलेला रेजिस्टन्स आहे तो आपण व्हॅरी करणार. सो आय एम जस्ट व्हॅरिंग. Okay, see it will shows this ammeter, it will shows the current flowing from field winding of the generator. जनरेटरच्या फील्ड वाइंडिंग मधून फ्लोनारा जो काही करंट असेल तो ह्या मीटर मध्ये शो होईल. दिस voltmeter it will shows that the induced EMF at the generator or the induced EMF of the generator when the field current it will be increases. ज्यावेळेस field current increase करतोय त्यावेळेस इंड्यूस होणारा EMF. हा व्होल्टमीटर जो आहे तो सप्लाय व्होल्टेज रीड करेल. Initially we are connecting this one, so we are just changing the rheostat आपण चेंज करू. जनरेटर फील्ड मध्ये हा rheostat कनेक्ट करू आणि मोटरच्या फील्ड मध्ये हा 1.4 एम्पियरचा rheostat कनेक्ट करू. ओके, सी आय विल मेक द कनेक्शन. मॅडम काय करतो? maximum resistance
प्रॅक्टिकल कितीला सव्वा
minimum position. Next. 1776. Huh? Very good. Very good.
कोई ना वो प्रॉब्लम है ना देखो सर
रेकॉर्डिंग में चला करते हैं कोई नहीं तो रेकॉर्डिंग में चला करते हैं तो देखिए खुद चला रेकॉर्डिंग सेटिंग में हमारे बंद नहीं कर
Hello, sir. सर आवाज येत नाही.
Wait for 5 minutes.
ओके ओके. सर आवाज येत नाही.
टर्मिनल चेंज करा. लोडचं नाही होय. Hello, am I audible now?
Yes, sir.
Okay. See the speed. We are giving rated supply voltage changed. So the speed of the machine 1625, near about 1625. Now, due to residual magnetism, there are some of the induced EMF. It will be present initially. याच्यामध्ये काहीतरी induced EMF आहे. Read the value. किती आहे? What is the value?
17.
40, 60. In between 60 and 80, there is 5 lines. Value of one line is nothing but 4, no? 64, 68, 72, 78, then 1, 2, 3, 4, 5, 5. So 65, 70, 75, 80. So this reading it becomes, किती reading आहे? 60 आणि 80 मध्ये 20 चा difference divided by 5. Value of one line is nothing but 4. So this reading is nothing but 76. Right? Line बघा कुठे आहे? This pointer it will be shows line less than 80. So less than 80 is nothing but 76 here. Now we are increasing the value of, we are decreasing the resistance and increasing the field current. आपण field current काय करतो? Increase करतो. I am wearing this rheostat. So I am wearing the rheostat. See the current. See the current 0.094. It is in ampere. 0.094. It is in ampere. See the voltage, that is induced EMF. किती आहे induced EMF? Induced EMF reading किती आहे? Here it is 80 and here it is 100. In between 80 and 100, difference between that is nothing but 20, and value of one line is nothing but 4, that is 84. Right? Again I will vary the resistance. मी परत resistance vary करतो. So see, after varying resistance, the current flowing through that of field winding, that is IF, is equals to 0.134. 0.134. The induced EMF E, it is equals to 112, right? 112. Again I will vary the resistance. See, the current it will be increases. Current काय झाला? Increase झाला, that is 0.17, and the induced EMF it is also increases 120, 124, 128, 132, 136. That means it is near about 132. 132 च्या जवळ आहे. Again I will take another one reading. आणखी एक reading घेऊया. So by varying this rheostat, the field current it will be increases. So field current is 0.218. 0.218. The induced EMF it becomes 156. Okay, 156. All of you take the radio. हा रीडिंग घेतलेत का सगळ्यांनी?
Yes, sir.
Okay, that means what is the conclusion? If we decrease the value of resistance which are connected in between the field, then current it will be increases. म्हणजे आपण काय करतोय? Current increase करतोय field winding मधला. When the current it will be increases, automatically the induced EMF of the generator it will be increases. Again another one we will take आणखी एक reading घेऊया. So again I will vary the resistance. So see, the current is nothing but 0.295. Current is nothing but 0.295, and the induced EMF it is nearly equal to 160, 180, and then 188, right? 188. Getting? Hello?
Yes, sir.
Okay, we will do the reverse procedure now. Just I will keep this rheostat at original position or previous position. After that, by varying this,
Hello. Audible no?
Yes, sir.
Okay. See. See. We have taken reading. We have taken some of the reading. So initially it will show some of the induced EMF. Initially तो काहीतरी induced EMF show करतोय. After that, if we increase the field current, आपण जो rheostat आहे तो vary करून field current increase करतोय. If we increase the field current, then induced EMF it will be increases. Induced EMF काय होते? Increase होते. So all of you draw this reading point on graph, and all of you draw the characteristics. So this characteristics is nothing but magnetization characteristics or the OCC, that is open circuit characteristics of DC generator. Okay. Getting लक्षात आले का? Hello.
Yes, sir.
Yes, sir.
Okay. So in this way we will conclude this today's practical, and we will stop here.